In this lesson, we are going to talk about circles and circumference, quite a bit of vocabulary that goes with circles. And our first definition is, what is a circle? A circle is the locus or set of all points in a plane equidistant from a point. And so actually a circle is really made up of just a bunch of teeny tiny points that are equidistant from that center point. And so we name this by its center point, and so it's either circle J or with the symbol circle and then J. Diameter, which you've probably heard of before, is a chord passing through the center. And so DG, that segment here, would be the diameter. And radius is half of the diameter. So it is a segment with endpoints at the center and on the circle. So that would be, we actually have three of them. We have GJ, we have JD, and we have JF. So what is a chord? We used that word up in our definition of a diameter, and it is a segment with endpoints on the circle. So it would be from A to C, if we kind of just thought of the segment, not the line, but AC would be a chord. And the diameter would actually be a chord as well. But it's nice just to name chord, and diameter is usually itself diameter. And so now let's move to tangent. Tangent is a line touching the circle once. A line touching the circle once. And so that would be this line right here, XM. Now we want to put arrows on our line symbol up above our two letters to indicate that it's a line and not a line segment. And so this point is called the point of tangency. And this line is the tangent line. Secant is our last word here, and it is a line intersecting a circle at 2 points. And so this is just basically a line that goes through the circle, touching at 2 points, not one, but two. And so it would be this line up here, AC, with our arrows, that would make it a secant. Without the arrows, just the segment itself is a chord. So secant is a line, and a tangent is a line. And all the rest of those were line segments. They stopped. The center of the circle we kind of talked about because we name it by its center point, and so it would be point J would be the center of that circle. So let's go ahead and practice after we review real quickly the formula for circumference and area. Then we'll practice some naming. So these you have used in middle school. We will use the area formula, pi r squared, in our next little mini unit with volume and a little bit of some composite area. Circumference, though, we will use, and there are two formulas. There is either pi times the diameter Or if you have the radius, it is 2 pi r because the diameter is the same thing as 2 times the radius. So these are equivalent equations for circumference. Diameter, we already talked about, is a segment that goes through the center point and touches 2 points on the edge, and then a segment that goes from the center point to the outside is a radius. Just a little recap before we start naming. So now we're going to go ahead and name a chord, a radius, and a diameter, and actually there's going to be more than one in the radius and diameter box, but chord, there really is only one specific chord if we didn't name our diameter, but from the 2 points touching each side of the circle, WZ would be our chord. The radius is going to go from the center to the side, so QY would be one, QZ would be another, QX, and the last one would be QW. And you could go the other direction with your letters. Diameter is going to go across and go through the center. So WY is one diameter, and then the other direction here, XZ, would be another diameter. So now we're going to go ahead and find radius and diameter with the information given to us here. RT is 21 centimeters. It wants us to find the length of QV, which is a radius. So if we have the diameter is 21, what is the radius? And remember, diameter is twice the length of the radius. So we're going to cut the diameter in half, and that is going to give us a radius of 10.5 centimeters. All right, next up we have the diameter given to us, and we want to find the circumference. So circumference, remember, is pi times diameter. So we're going to take 120 and multiply it times pi. Make sure to use the pi button on your calculator and not 3.14, otherwise it will kind of round that answer and make it off just a little bit. So if we plug that in, we are going to get 376.99, which we're going to go ahead and just round up to 377 feet. Next one, we're going to work backwards. So given the circumference, we're going to write out our circumference formula, pi times diameter, and this time we're going to replace the C for circumference with a 65.4. And then we are going to divide by pi to get the diameter alone. And so 65.4 divided by pi in our calculator is going to give us 20.82, which if we cut it in half to get our radius, it would give us 10.41. Keep in mind that whenever you're in the same circle, all the radii are the same. They're all congruent in the same circle. Same with diameter. They are going to be the same in the same circle. Here we have 2 points of intersection between two circles. Here just 1 point, and here no points of intersection. This is when it's kind of like a bullseye. They are called concentric circles. If two circles have the same radius, well, then they're congruent. And all circles are similar to each other. So let's go ahead and label a number 5 here. We are given the diameter of circle X. So that would mean that, well, this is the radius, right? So we need to cut that in half, and that would mean that the radius is 11 for circle X. And then the radius is going to be half of 16, or 8, for circle Y. And then they give us one other piece of information here, that the WZ is 5. So with this being 5 and the total being 8, what's left for ZY here would have to be 3. And what's left here, if this is 5, then this would have to be 6 to add up to our 11. And now we're going to find XY, the whole length, which we have these 3 pieces that make up XY, 6, 5, and 3, which totals 14. And so now our last part here is a polygon is inscribed. Think inside when it's inscribed in a circle if all of its vertices lie on a circle. So we're going to draw a circle, and then we're going to go ahead and put a quadrilateral with kind of chords, basically, kind of a trapezoidish-like looking thing, with a point in the center of K, because it is circle K, and then each vertex L, M, N, P, there. So now we have a polygon that is inscribed in a circle. The circle K is circumscribed about the quadrilateral, meaning it is around. Think circumference. So the circle is around or circumscribed around the quadrilateral. And then go ahead and take a moment to draw a center of the circle, a radius, a diameter, and a chord. See if you've got the vocab down. And just remember that radius and diameter both touch the center of the circle, but a chord does not necessarily. Chord is just going from one side to the other there.